Yes, Sarah.
Hello.
Hello, how are you? So,
Good. How are you?
doing fine. Thank you. Thank you. I'm going to wear my hat here.
It looks nice.
Yeah, thank you. Yeah. No, actually, I had this morning surgery in my head, so there's a removal
Oh,
of the skin. That's why I don't want to show my bulk here in any way. Okay. All right.
well, the hat looks good nonetheless.
Okay. Yeah. I was going to ask then, if I understood you correctly, we each have 17 minutes, right? So,
So it'll be a little less than that. We have about 45 minutes total, and
okay.
there's three speakers. So we're gonna save Q&A for the end. It'll be the last 10 minutes. So that gives us about 11, 12 minutes a person.
Okay, sure.
Uh,
Okay.
So
Yeah,
I'll reiterate that to the other speakers as well.
sure.
But yeah, I think about 11, 12 minutes. And my colleague Ray, he's going to be joining as well. He's going to send everyone like a little 2-minute warning in the chat when it's getting
Right, right.
close to your time being up.
Yeah, yeah, yeah. And by the way, since I have you here, I was wondering, there's no big hurry because also, like next week I'm traveling, but it would be nice to get together because every year since I teach the senior design course, I talk to the students about, job fairs and so forth, and I tell them about the companies that are coming because
Yeah.
I've been here for quite a bit of time. And I think it would be important, to be honest, to make you aware also of some companies that I really feel we've been kind of missing for some reason or another.
Yeah.
Coincidentally, tomorrow I'm talking to somebody from Covestro. And
Okay.
yeah, so it's again,
Yeah, I mean, as you have conversations with folks, like if you have a contact person you want me to touch base with,
sure.
I can get that information from you and then make sure they're given, all of our materials about signing up for the fairs and what we have to offer and try to get them back.
Sure, sure. No, I'd be more than happy to do that.
Yeah, so let's touch base after you get back. And I'm happy we could sit down and have a conversation and talk through some companies or other things you want to see and do some
Yeah, right, right.
brainstorming.
Yeah, yeah, yeah. Yeah, because I have the list of, I would say, probably at least 30, 40 companies that have
Mhm.
been, one way or another recruited in the past. And I think, unfortunately, to be honest, a number of them I've seen have not shown up for quite some time. And well, in any event, just
It might be worth circling back with them over this summer and, maybe they have a new recruiting person or someone we can, get
yeah, yeah,
excited about coming back
yeah,
here and
yeah.
talking with our
Well,
students.
yeah, maybe one question I have. So are you, you have your own job fair, but then the College of Engineering has their own as well, right? Yeah.
Yes.
And you see, in my opinion, that's just been a little bit part of the problem in the sense
Yeah.
that, well, they get a little confused and, well, so, but anyway, that's,
Yeah. I'm hoping that we can, market our job fair that's really more tailored to, the non-ECE students,
right.
more this fall, really get the word out to students. I'm working with, some of the professors. I really want to try to get, maybe a slide we put up and ask folks to put it up during class
Oh,
or
yeah, yeah.
mention, we have this going on. Because I think that one of the problems is that they really just don't read my emails or many people's emails. So if we can have faculty and staff that are in the department talking about it when they actually have them face to face,
Oh,
hopefully
yeah.
that could get more folks interested.
Right, 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 right. Exactly. Well, amen. So then it's going to be three speakers because I was a little confused as to whether it was Michael and Aaron sharing, but they're each talking about 10, 11 minutes, you said, right?
Yep, yep,
Okay.
yep. So each of y'all will have 10, 11 minutes. I'll do a brief little introduction. I'm going to have you start. So we'll jump right in with you. And then we'll have Michael and Aaron follow. And then we'll do Q&A at the end.
Okay, sure. Okay, sounds good.
Okay. Well, everyone else should be joining momentarily. So
Right, right.
just make sure I've got everything up on my end.
We have John joining. Hi, John, how are you? Sorry, I was unable to make your talk because that's another meeting going on, so.
Oh, we can't hear you, Joanne.
Well, at least we can see you're trying to talk, but.
Hi, Erin. Oh, you're on mute.
Okay, now I'm not on mute.
There we go.
How are you?
I'm good. How are you?
I'm fine. I'm fine.
So just to give you a little quick update, we're going to get started right around 2:35. I'm going to do a little introduction for all of the speakers. We're going to have Ignacio kick us off first. You're going to go second, and Michael's going to go third. And you all will have about like 10, 11 minutes to speak. And then
one interruption. Michael will speak for both of us. There is no. That's what Michael and me and I decided to do. I will be just in the background in case.
Okay, all right. Well, then you guys will have a little bit longer then, since it's both of your discussion.
There's 17 originally.
Yeah, and then what we'll plan to do is do 10 minutes Q&A and at the end. And when you've got about 2 minutes left in your time, we'll send you a little chat and let you know. So we'll send it to Michael then.
Yeah.
Okay, great. We'll probably have some folks starting to trickle in as the last session ends, but we will give them a few minutes before we jump in and get started.
Yep.
Hello, good.
Hi, hello. We're just going to give it a couple minutes and then we're going to go ahead and get started. Hi, Michael.
Hey, good afternoon.
Good afternoon. Just a heads up before we get started, I'll let you know that Ignacio is going to kick us off, and then I'll have you and Aaron go second, okay? And we'll give you a little 2-minute warning when you get close to your time.
Sure, of course. Thank you.
Okay, great. All right, we'll just hang out till 2:36 and then I'll get us started. Oh, all right, we're just gonna go for it. We have precious small amount of time together, so I'm just gonna go ahead and kick us off. So hello and welcome to Carnegie Mellon University's Campus Engagement Day. My name is Sarah Kurz and I'm joined today with Ray Mzgorski, who is one of our career consultants, along with myself in the Career and Professional Development Center. Today's session is going to feature speakers from programs at the university that prepare for students for careers in materials, chemical, and process engineering. Each speaker will present a little bit about their department and our program, and then we'll turn it over to the employers for Q&A at the end of the session. For the presentation portion, please keep your microphones muted, and please save your questions for the Q&A at the end of the presentations. So first, I'd like to introduce today's speakers. We have Ignacio Grossman from Chemical Engineering, and we have Aaron Inspector and Michael Bachsteller from Materials Science. So with that, we will go ahead and get started with our presentations. So Ignacio, please feel free to go ahead and kick us off.
All right. Do you see my screen, the slides?
Yes.
Okay, good. Okay. Well, thank you very much. It's a pleasure to give you an overview about chemical engineering here at Carnegie Mellon. What I'll be presenting is actually jointly with Professor Bob Tilton, who's the chair of our undergraduate committee. Now, yeah, and I know that not necessarily all of you know what is chemical engineering. And I would say in many ways, the way you could think of it is kind of a broad discipline in the sense it's based on chemistry, mathematics, and physics, basic sciences, but then applying concepts of engineering science and process systems engineering for the development and commercialization of new processes and products. And in a nutshell, what chemical engineers do is design and managing new processes, to convert raw materials into value-added products, then developing a wide variety of new products, as we'll see. And then also, actually, it's a broad discipline in the sense it also leads to innovation in areas like biomedical engineering and environmental engineering. Now, the chemical engineering program here at Carnegie Mellon actually was founded in 1905, so it's got a long tradition, as you can see, and it is the department that offers one undergraduate degree, namely Bachelor's of Science in Chemical Engineering. I should also mention that students, can also earn, in addition to the Bachelor's in Science, or Bachelor of Science in Chemical Engineering, like double majors, double degrees, as they're called. The most popular ones are biomedical engineering and engineering and public policy. Then students also often do minors. The most common minors, we have a strong program in colors, polymers, and surfaces. We have one joined with the Tepper Business School on supply chain and operations management. Then, of course, one that's becoming very popular is a minor in computer science. We also offer an integrated master's and bachelor's degree. In other words, the idea is to complete this in a 5-year in an integrated way. And then we also offer, for example, as I'll describe briefly, a number of study abroad programs, and also with the option of doing a 1-year internship between the junior and the senior year. The other thing about our department, our faculty is very, committed, of course, to research, but also in the sense of trying to involve undergraduate, students in order to do research, which, helps to close a close interaction between faculty and the students. Now, so here, when I talk about new processes, I thought, well, since we're very close to Monaca, as you probably have heard, the Shell is, completing the construction of a new plant. And again, this is just like one example of a, large scale chemical process that typically, involves largely chemical engineers, because what is involved here is basically, converting the ethane into ethylene and polyethylene that, then gets, shipped to various parts of the country. At the same time, for example, a recent development has been in the area of direct air capture of CO2, environmental, how do you capture CO2 from air? And again, that's, as you can see, sort of with the flow sheet down here, it's again a typical process where, the air is captured and the CO2 is then removed by adsorption, a number of different processes, and eventually converted into calcium carbonate. Now, then in terms of new products, as you can see, there's a big variety, from industrial products, consumer products, energy, food products, automotive, and recently was also been very, as you have read, I'm sure, in the news, the development of vaccines. Moderna was actually, for example, pioneered by Professor Bob Langer at MIT, who's in chemical engineering. So product is also very much part of the chemical engineering culture. Now, so what is the education in chemical engineering all about? Well, obviously it starts with fundamental sciences, as I mentioned before, chemistry, physics, increasingly also some biochemistry, connection with biology. And then in terms of course, mathematics, calculus, differential equations, and linear algebra. And it's those sciences and those mathematics that then provide sort of the basis of what we call chemical engineering sciences. And this means basically thermodynamics, and then fluid mechanics, heat and mass transfer that are often known as transport phenomena, and then also increasingly moving towards the molecular level, namely providing molecular foundations for some of these phenomena. The idea then here is having that knowledge base. What we do, we use extensively mathematical models, for computing, and what this is all about is basically with the purpose of designing chemical reactors, a variety of unit operations, like especially separation, distillation columns. Then we have the area of process control, the real-time control plant like the one that we saw. Optimization is very much an area of interest, also in our department. We do offer that as a course, which is kind of unique. Then we have, of course, 2 courses on design. The major one, the process systems design, that's for the case of process flow sheets. But then also we offer at the senior level a course on product design. And basically the next slide here shows how the different courses are related to each other. So here on the left we have the basics on the chemistry side, modern chemistry, chem, bio, organic, and biochemistry. Then we have 2 courses on physics. Mathematics, we have basically 3 courses, a sequence of 3 calc courses, because we actually teach a 4th math course, because we have found that teaching differential equations and also some linear algebra is usually done best by our faculty, because we can tailor it to our needs. And then there's also a course in computer science, and pretty much a sequence, as you can see. It starts with Intro to Chemie, which is sort of mass energy balances. Then we have thermodynamic courses. These 2 courses are actually now being merged. And then basically what happens with the after the chemie mass, so here on the right, again, we have fluid mechanics, heat and mass transfer, as mentioned. They do involve actually a lab that is performed as part of the course. And same with unit operations, especially separation type of systems. This then interacts with the course that we have on process control. And then the sequence in the senior year, which starts in the fall, process design, and then in the spring is product design and optimization. So these are the basic courses that our students in chemical engineering will be taking. But also, as is customary here at the Carnegie Mellon, students have to take 8 humanities, social sciences courses, 1 per semester. That means a total of 8 courses. And then also our students that can take 5 free electives, and these electives are the ones that then give rise to the possibility of doing, again, what I mentioned before, the double major, the engineering policy, biomedical, or for example, minor computer science, or the one on supply chain. And that's if some students who, for example, even take these electives in very different departments, even including sometimes philosophy and music. So they tend to be very broad based. Now, one of the things that is very noticeable about our department is also the commitment of our faculty to education. And I think one way to show this is a number of textbooks that we have produced in our department. And for example, in the senior design course, we follow this textbook, Systematic Methods of Chemical Process Design. This actually was developed by our department, by our faculty. Likewise, recently in the optimization module, we make use of Pyomo. This is the work of Carl Laird, who has just joined us, basically Python-based, but again, gives you sort of an idea of the commitment that our faculty have to education. Another interesting thing that we're very fortunate to have the participation of Professor Jeff Sirola. He's actually not at Purdue, but he, when he was here, he actually produced an incredible online course in industrial chemical technologies. Really gives a tremendous and nice overview of the whole chemical industry. Now, What do we expect to accomplish in the program? Well, following, of course, the guidelines by ABIT, the basics, right? Math, science, engineering, as I mentioned before, being able to design experiments, analyze them, to be able to design a chemical process, and to identify and formulate engineering problems. So these are sort of the basics, what you would expect from engineering. Then, of course, also, being, or broadening, looking into modern engineering tools. We use a lot of simulation. We use, for example, Aspen Plus, and as I mentioned before, Pyoma is now also being used. Then we also stress the importance of multidisciplinary teams, where a lot of the projects involve work in formal groups. And then also understanding professional and ethical responsibility. We do that through some special seminar courses that we have, where we invite actually people from industry and also people from campus to talk about ethics, for example. And then communication. Communication is also something that we stress a lot, both in terms of oral and written presentation. And lastly, what we also want to do here is, of course, to produce engineers that have a broad knowledge, appreciation for global societal context, appreciation for lifelong learning, and knowledge of contemporary issues. In fact, a good example is, as I mentioned before, the process design course. Every year, we address a problem that is currently relevant. For example, 2 years ago, we did precisely a project on CO2 capture that I presented in the figure before. Now, another unique thing about our program is that we have a fairly active program on study abroad that you can see actually involves a 1-year exchanges with Imperial College in the UK, with Aachen in Germany. It's also a 1-year program. We have a summer program with the University of Dortmund in Germany. And then we have semester exchanges with the Universidad Nacional del Litoral. This is in Argentina, and with Yonsei in South Korea. And, this actually is a two-way street. We do receive students from these universities, which also sort of helps us to enrich the environment that our students have. And then, of course, needless to say, students who go to those universities, also get exposed to, very different type of, environments and modes of learning. Now, in terms of, against undergraduate research, as I mentioned before, that's something that we emphasize very much. I have to give you credit, especially to Professor Bob Tilton. We have this special program, Chemical Engineering Summer Scholars, that is all available to sophomore and junior years. And then also during the year, we give academic credit to those students who actually do research. Also, of course, in the summer, we expect often our students to do internships in industry, but we also have actually a special program that we call PISIS. It's a 1 year between the junior and the senior year. I have to admit, this has the recent past has not happened very often because of the pandemic, but a few students do have this unique experience where they take off for 1 year and spend 1 year in industry. And in my experience of what I've seen, students who come back, have become really much more mature and with a better appreciation of chemical engineering. Now, so again, we have this collaborative culture. We also, in terms of diversity, have actually more than 50% women students in chemical engineering. And through the American Institute of Chemical Engineers, we have a very strong student chapter. Our students are very active as part of that. And we have, again, these programs like the CMU Pulse Chemical Car Competition, which is a national competition that takes place every year at the annual meeting, and the CMU Cube. So again, our students, go through this nice enriched environment. Now, another very important point is, of course, you may ask, well, who hires our students? And again, here we're listing companies that have hired our students, in the period of 2014 to 2020. You can see in the area of materials, pharmaceuticals, biotechnology, area of chemicals, engineering and consulting, consumer and food products, then automotive electronics, then software companies, finance have also been hiring our students. Then we have also, especially energy companies, needless to say, they tend to be major employers. And our students, on average, have been, paid fairly well. And as you can also see through the map, they've been, they concentrated still a bit more towards the East Coast. But again, you see a large variety of companies. Now, of course, it's difficult to read all these names and get a little bit of a sense, but I thought, well, let me show you at least the statistics of 2019. This is just a year before the pandemic started, because that was kind of the typical type of situation that we saw there. So from the 55 students that we hired, that we graduated, 27 got industrial jobs, and you can see, at least in the past, companies like ExxonMobil and Merck have been major employers. But interesting enough, we've also had the consulting companies like Accenture, Deloitte, Price Waterhouse, and then of course, a number of companies. So some of them consistently every year have hired, like for example, Air Products, Procter & Gamble, and so forth. Okay, so again, this is just to give you a bit of a sense. And then of course, a good number of our students also decide to go to graduate school, whether to PhD or continue to be masters. And usually 1 or 2 students at least, go to medical school. So if I had to then summarize what we have here in chemical engineering at Carnegie Mellon, I think we do emphasize very much the fundamentals. It is very important for us to emphasize, again, molecular phenomena, transport phenomena. I think our curriculum is also unique because of the design courses. In many universities, design courses are typically now taught by retired engineers. That's not the case here at Carnegie Mellon. It's actually faculty who teach these courses who have actually written textbooks, and we have, again, unique projects and team experience for our students. And lastly, again, that we do emphasize a multidisciplinary and broad education, from the minors that I mentioned before. So with this, I'd like to thank very much your attention, and I guess when the time comes, I'll be happy to answer any questions then. Okay, thank you very much then.
Thank you, Ignacio. If you have any questions for Ignacio, we will save them for the Q&A at the end, and we are going to go and turn it over to Michael and Aaron.
Can you hear me and see the slides?
Yes, you're just not in presenter view.
Excellent. Yes. So, yeah. So this was fantastic, Ignacio. This was great. My presentation will be somewhat. Our presentation will be somewhat less detailed, perhaps, but I hope still being able to give you a good idea about what our program is about. And then, of course, we can answer any question you have at the end. I will start with the presentation. I'm grateful to Aaron for his contribution, and Aaron can, of course, help perhaps answering questions that might come up. So let me give you just, as a start, material science and engineering is, of course, based on materials, which, if you look at, technologies and what drives technologies, we find that materials, of course, are all around us, and they drive much of what's going on in innovation. There has been a fantastic book by a colleague at Cornell about the substance of civilizations, which I think is very nicely encapsulates the role of materials in the evolution of human society. So to briefly encapsulate what material science and engineering is about, it is really a rather unique engineering discipline in that it involves basic science and engineering principles. It involves the discovery of novel materials, and it does so by establishing the basic relationships between structure and properties of materials. And it also encapsulates the application, so the engineering of materials, the application and novel material solutions. That requires understanding of how the structure and thus the properties of materials can be manipulated by varying, say, processing of materials, and also understanding the governing parameters that control how materials will perform in applications. So often material science and engineering as a field is encapsulated in what we call the 4 pillars of material science and engineering, which basically represent the 4 important components, structure, properties, processing, and performance, that constitute what we are interested in. If in a way, the course content and much of what's going on in research in the field of material science is really can be thought of as bringing together fields such as solid state chemistry, solid state physics, as well as aspects of mechanical, chemical, and electrical engineering. Our department, just as the Department of Chemical Engineering, Material Science and Engineering, was one of the first departments that opened at the university on October 16 in 1905. And like many other departments, like all departments in material science and engineering, like most, I should say, the department evolved out of the metallurgy department. The field material science and engineering is very much rooted in the field of metal research, which drove, of course, the industrial revolution. And over time, as the recognition materialized that it is not just metals, but also the other classes of materials that can form the basis of innovations. Ceramics became more important, polymers became more important, mixtures of these three different classes of materials became important. And so the department evolved into the Department of Metallurgy and Materials Research to acknowledge the more broader relevance of materials. Later, the Department of Metallurgical Engineering and Materials Research. And since 1992, we are officially the Department of Material Science and Engineering. This is to reflect that the fields of material has broadened to encapsulate what we consider today are the four dominant pillars of material science and engineering. It is metals, it is ceramics, it is polymers, and it is composites, which basically involve mixtures of these materials. Since 2021, Elizabeth Dickey is our department head. She just joined last year, and we are very fortunate to have her. To give you an idea about the composition of the department, we currently have a student population of, these are 1 year old data, so it might, the numbers might have actually increased a little bit, but this is about the size that we have. We have 252 students in the department. Of these are 111 BS students, undergrad students, so they are in the primary material science and engineering program. And then we have about 140 graduate students, which break down into 39 master students and 102 PhD students. From the numbers, we can gather that this is a very research intense department. So we have about an even number of undergrad and graduate students, and it reflects itself in the curriculum that emphasizes undergraduate research. So giving undergrad students the opportunity to participate in research groups outside of the curriculum. The population breaks down about evenly in women and men, although there's certainly room for us to improve. And in terms of our faculty, we are 23 core faculty in the department. We offer different types of faculty appointment. We have courtesy faculty, 12 courtesy faculty. Courtesy faculty are faculty, the primary affiliation of whom is in a different department, might be sciences, might be engineering departments. And adjunct faculty, those are industrial researchers that hold the rank of faculty so that they can participate in student advising. Our current alumni population encompasses about 2,000 students, to which we hold very close contact. So just to give you a brief idea about the different research areas that are being pursued in the department. So we cover all areas in the most, I would say all areas of material science and engineering, with the one notable exception of nuclear materials, which is simply because we don't have really access to according facilities. We have an about even representation in the number of faculty in terms of soft materials and inorganic materials. Inorganic materials breaking down into, say, metals, into magnetic materials, into electronic materials. If we take all these different groups together, then we would have about 1/3 of the faculty represented in the soft material group, soft and nanomaterial. Material characterization plays an important role across all research efforts in material science and engineering, and computational material science is an important thrust where we have about 5 faculty members which are exclusively devoted to computational material research, doing research at a different length scales, predicting and designing materials from the atomic scale all the way to the macroscopic scale. An important departmental expertise is in the area of characterization. One of the core interests of material scientists is to understand structure-property relations and to establish an important concept within this context is to realize that it is structure that occurs on multiple length scales. And as a consequence, material science and engineering departments are typically very focused on material characterization, and so are we. We host the Earl and Mary Roberts Material Characterization Facility, which is a shared facility that hosts a large number of electron microscopes, X-ray characterization, mechanical characterization, and other type of characterization equipment, which is available to researchers both within the department, other departments, as well as outside researchers from industry. This is just a few examples of the research that is being performed by faculty members in the department. It covers all areas from process metallurgy to nanomaterials, 3D printing, computational materials and its applications to material characterization and 3D printing, magnetic materials, and many other areas. Now, to briefly describe to you the curriculum, it is a 4-year program, 379 units. I didn't break it down the way that Ignacio is. I will just say that our program is also ABET accredited. So the primary objective is, of course, to empower students to solve advanced material science and engineering problems. We also want them to be able to design material solutions that solve challenges, and we want them to be able to effectively communicate material science concepts. Like chemical engineering, we offer double major programs that the students can enroll in, and without adding a substantial number of additional units, it might be 5, it might be 7, depending on the option, can achieve an additional double major in EPP or BME. There's also a 5-year integrated course master option in the department. This is just a very coarse breakdown in what the typical curriculum looks like, and students at CIT, the Carnegie Institute of Technology, will enroll in a basic set of natural sciences, computer science courses. They will form the basis of what we want engineers to know about. So in the first year, students are actually affiliated with or associated with the college rather than individual departments. At the end of the first year, students make a selection of their program and then join the respective program. In the sophomore year, year number 2, is very heavy in core courses. This is where foundational skills are being imparted to students. That involves characterization. This involves understanding of material structure, of basic concepts of thermodynamics, of basic concepts of kinetics. Then in the junior year, students progress to courses that will then bring together the foundational skills that were provided to students in year number 2. Also in the junior year, space opens up to allow students to tailor their curriculum to their particular interests. This is indicated here with elective heavy. So students have the possibility to select students within the College of Engineering, as well as computer science and science, with some restrictions to fit their particular interests. Should students decide to enroll in one of the double major program, then the core courses of the second major will replace the elective courses in the junior year. In the senior year, this spirit of the junior year is continued in the senior year, and the senior year closes with the capstone design project, which students complete. Currently, to give you an idea about the double major programs, about 60% of our students pursue the additional double major in biomedical engineering. It's a very successful, about 50%, I should say, in biomedical engineering, about 10% in engineering and public policy. The double major with biomedical engineering is a very popular degree in our program. What do our students do after graduation? It breaks about in 50-50, pursuing industrial position as well as academia. We find a wide range of industry. Our students find a home in a wide range of industries. And just as Ignacio mentioned, in the past years, we found increasing interest from consulting companies, also financial companies that were interested in hiring the students. In academia, we find that our students regularly find their place in the highest ranked department programs within the country. This gives you an idea about salaries as well as where to find our students. We keep a close eye on our graduates. However, we are just in the process of compiling data for our international students. So in the next year, we hope to be able to provide an even bigger map that will show you where our students have found a home. So there are a few alumni that I wanted to point out in particular. So we encourage, as part of the curriculum, independent thinking, solution of problems. We find several of our students were successful as founders of their own company. And I'm particularly proud, and this is not to single out anyone, but I'm particularly proud of James, who was personally my first undergrad student researcher, who founded the company Appeal. That is a new approach to conserve and prolong the lifetime of vegetables and fruits. And you will find Appeal as a label of many of the grapes and what you can buy at grocery stores such as Costco. Very briefly, I want to mention a few words about the master programs that are offered in the department. Aaron is really the expert in it, so he will correct me if I say something wrong. We offer a variety of master options in the department. There is an integrated course masters. There's also a course-based master in material science. There's then a research-based master in material science, and there's a number of collaborative master programs that we are currently in the process of establishing, and that have just, I believe, even graduated their first students, such as the master in additive manufacturing. Just to give you an idea what the master curriculum typically entails. So this is an example of the Master in Material Science and Engineering, which is course-based option, which involves 96 units of courseworks. And similar to the undergrad curriculum, it breaks down into required units that we require students to take within the department. This will be core courses, it will be thermodynamics, it will be kinetics, the basic and structure, of course, the basic material science core curriculum. And this will then be complemented both by electives that are engineering based as well as outside the engineering college. In addition to the course-based master, there's a research master, which is very popular in the department. It involves additional required units that the students have to do, 70 units of research in the department, culminating in a final report, typically a thesis that the students will present, that the students will have to submit to the department, to the advisor and the department at the conclusion of the project. This concludes the presentation of our program. And Aaron, I'm not sure if you want to make an additional comment.
Unmuted. Great. No comments.
Okay, so then I think we can, I'm sorry, I flipped to the wrong side. I think we can move to the questions. Sarah.
Great, thanks everyone for your presentations. We'll move to Q&A now. So if anyone on the call has any questions, feel free to either unmute and ask them, or you can type them in the chat, and we'll give folks a moment to ask their questions. And if we don't have any to begin with, I have one that can get us started. So if you all would like to jump in and talk about this a little bit more, how do the faculty and CMU prepare students for diverse career pathways that are maybe beyond just the traditional scope of the major?
Well, if I can maybe make a couple of comments there. So again, as you saw, what's been interesting is to see that our students, they do, some of them go to what you could consider to be traditional chemical engineering companies like, ExxonMobil, Dow, and so forth. But then you also see, students going, as we saw, for example, to consulting companies. Now, why is that? I would say the major reason for this is, for example, in our faculty, and I didn't really talk much really about our faculty, but we have a strong component of systems engineering. So systems engineering sort of allows you, to give you an extreme example, if I may call it extreme, it turns out that the chief scientist at Amazon is actually chemical engineering. That's Ross Algar. He's actually a PhD from chemical engineering, and he's actually recruited, 3 to 4 PhD students in chemical engineering. That's of course at the graduate level, but gives you a little bit of an idea that because we have especially the system component, that definitely tends to broaden that aspect. But then at the same time, as we also saw, there's been the emphasis towards the molecular level. So that means that basically, again, especially as I mentioned, the area of colloids, polymers, and surfaces, that again, goes well beyond, for example, the area of cosmetics, that you would traditionally not think is part of your core chemical engineering, but we have actually some of our students working in that area. And the whole reason, I think, why they do that is, again, because they get this, exposure to the different areas, whether it's really more on the side of the sciences or science of engineering, or the side on systems engineering. And likewise, as I also mentioned, we do have also like that special program on supply chain that was actually created together with a professor at Tepper Business School, where we both saw the need that some of our students, when they wanted to do a minor in business, they had the quantitative, type of skills to go beyond sort of the traditional sort of business, undergrad degree. And that's, again, just an example of how we're trying to broaden our students. Okay.
If I can just add to it, I think to some extent, I think it is also due to the general layout, perhaps, or it is at least supported by the general layout of the curriculum at Carnegie Mellon. I think that if you look at the undergraduate curriculum, not just material science or chemical engineering, other really all programs within CIT, there is a rather balanced distribution of courses, of requirements that students have to fulfill, that involves naturally a focus on the discipline that students focus on, but it leaves ample room and puts some very definite requirements on students to take courses outside the program, broaden their perspective, and beef up in areas such as computation, science, humanities. I think it just helps to generally also broaden the interests that students have, and equip them more broadly, give a little bit more holistic view perhaps by the time they graduate.
I had a question. I have one for, I guess, Professor Grossman and also Professor Boxstaller about the some of the undergrad summer programs. I'm Terumi McKenna. I graduated way back as I got my PhD with Professor Prevey. It was Terumi Nagase. So yeah, Professor Grossman, nice to see you. I had a question. Right now you have a program called Chemical Engineering Summer Scholars and also full year industrial internship opportunity. And the past like 2 or 3 years, we have hired Carnegie Mellon undergrads for summer internships. And in fact, we made an offer to one who is going to start. He's from ECE. So we've been very happy and we want to develop the relationship more. So I just wanted to ask, what is the Summer Scholars Program and what is the full year industrial internship opportunity? It's in person, right? I mean, the person would come out to our site, or is it remote?
Yeah, well, the research is basically, to be honest, done within the department, in the sense that faculty who, are doing research in the various areas, like, for example, I didn't mention, but roughly in chemical engineering, we have the bio area, we have the soft materials, we have the area of, air quality, and then we have the area of catalysis, and then the area of process systems. So each of the faculty there, have usually, as you saw, for example, when you work with Professor Dennis Prevey, they often have their research projects, and they, we try to involve them, the undergrads, often, through also our graduate students, so they can work closely with them and get a lot of attention. We still meet with the students, say, typically once per week, but that experience, I would say, is really confined to Carnegie Mellon. Now, the experience, for example, we do encourage, because as I mentioned before, we do have this special seminar program, 2 seminar programs, where we bring in people from industry to talk to our students, and we do encourage our students very much to apply to summer internships, because they get the message, look, this is one way for you to learn how industry works, and also for companies to get to know you, because often the companies like the idea of, as I'm sure you do, of watching sort of a student come in for the summer, and then, trying to see if that student, would be kind of a nice fit in the program. So that's the, now that part of the program, though, is really driven more, if you wish, by when companies come to interview in the fall, and offer the summer internships. Now, the 1 year internship that I indicated has a name called PISIS. I do have to admit that partly because of the pandemic and so forth, we have not had that for the last couple of years. But the idea here, it would be typically only very few students who would do that, who would say, I take off typically between the junior and the senior year. They take off for a full year. And we've had actually, and if you're interested, of course, in having students like that, please do let me know, because I'm the one who supposedly is coordinating that program. So we would love to, hear from you. We've had already, a couple of students who are actually now talking to companies about doing such 1 year program. So the idea is to say, during that 1 year, there will be also in the company rotating at different, positions and so forth, to get that very rich exposure. Okay.
Okay, thank you. And then Professor Boxstaller, about the some technology ventures, including summer internship, they take courses during the year and in the summer.
So we had several students. So we also have collaborations with programs with several universities abroad. And I'm not sure if I will be able to recollect all. The most important, the most favorite popular ones among students is EPFL, of course, in Switzerland. It's Tokyo Institute of Technology.
Okay.
And we also have had student exchange with RWTH Aachen that Ignacio just mentioned. Those have been in the past the most popular programs. We advertise to students the existence of these programs as part of our core courses. I would say the participation, you know, there are many reasons for it. The participation is certainly something that we want to, we certainly encourage students to get an experience abroad, and we would love to see a greater number of students to participate. If I'm not mistaken, it was about 10 students in the past, I would say 4 years. So rather low participation rate. I think we can still be proud about the students that we could help to realize those visits, but it is difficult for students at Carnegie Mellon to participate and, you know, to find time and get everything in their schedule. Yeah, those programs are such, by the way, that the curriculum and courses have been approved so that there's very clear for students when they go to institutions abroad and take a particular course, which units they will be able to count towards which fulfillment requirement.
Thank you very much.
Yeah, I'm not sure if this answered all your question. If I misunderstood, just.
Oh, no, I appreciate it. Thank you.
Yeah, if I can make just a very quick comment. So with the exchange programs that I indicated, just as Professor Bachsteller explained, we already have pre-assigned what courses they should be taking over there, because in that way, whether they go for a full year, for a full semester, the students are assured that they will then be transferred to Carnegie Mellon for their credit. So that's all been prearranged. Okay, and we've actually, I would say, over the last few years, have had typically per year something like 8 to 10 students out of, let's say, a class of 50 who to go to these exchange programs. Okay.
Thank you very much. And I really enjoyed my time at CMU. So
yeah, thank you.
Yeah.
That's good to see you.
Thank you, everyone. So just to be cognizant of time and that folks might be wanting to go to the last session, we are going to wrap up for today. Thank you to all of our wonderful presenters and speakers, and to our employers for attending. If you have any further questions and you cannot find any of our speakers' information for some reason, it's out there on the CMU website. But if you'd like to get in contact with me, I've dropped my email in the chat as well. So thanks again, everyone, for attending today and for your participation. Have a great rest of your afternoon.
Thank you. Have a nice day.
Thank you. Bye-bye.
Pleasure seeing you, Professor Grossman.
Yeah, I saw your name and said, "Oh, I think I know you." What are you doing right now, by the way?
I'm at Skibo Energy here. We're just listening and seeing if there are any opportunities to partner up with research, or even bring on undergraduates with and do some research with undergraduates. So, but I think we'll look into what you said about the 2 programs, and maybe reach out.
That's good. Well, it was nice seeing you. Yeah, when I saw this, I thought, I think I know this guy. Okay, I hope everything goes well with you then.
Yeah,
okay?
thank you. Thank you.
Yeah. Bye.
Bye.